to Unit 8, Lesson 1, where we will learn how to interpret a histogram. Unit 8 is about data analysis and statistics. Before we start analyzing data, we should talk about what it is. A data set is a collection of information that can be used to describe a population. Examples of this could include the height of students, the finishing times of runners in a race, or the weight of each book in a library. Here's an example of what data might look like in something called a data table. This can be a little difficult to understand because it's kind of hard to see any patterns with this raw data. So in this lesson, we're going to learn about a statistical graph called a histogram that can make it easier to see this data. So here's what that same data looks like in the form of a histogram. It includes several important components: a frequency axis, different intervals for your quantitative data, and bars communicating how many data values fall in each of those ranges. For this particular histogram, we're looking at a baseball player named Julio Franco's career number of RBIs, which is short for runs batted in baseball. Our first important vocab word is a bin. A bin is a range of values within your quantitative data. For this histogram, we have a bin here, 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 and here. To read what numbers go into each of these bins, we're going to use the concept of a lower class limit. Each of these numbers represents the lowest value in each bin. So this first bin starts at 0 and then cuts off just before 20, which would mean 19. So this represents 0 to 19 RBIs in a season. This next bin starts at 20 and cuts off just before 40, so 20 to 39. Now this pattern will continue for the other 3 bars, and now we have an idea of what range of values go with each bin. Now the next component to focus on is the frequency component. This is going to tell you how many data values fall in each of those bins. So this first bar has a height of 8. That means that he had 8 seasons of somewhere between 0 and 19 RBIs. We don't know what the specific numbers are. We just know that he had 8 seasons somewhere in that range. This next bar has a height of 4, meaning there are 4 data values between 20 and 39, which in the context of this problem means he had 4 seasons with somewhere between 20 and 39 RBIs. Each of the remaining bars had 5. That means he had 5 seasons with somewhere between 40 and 59 RBIs, 5 somewhere between 60 and 79, and 5 somewhere between 80 and 99. Now we don't always write these things on our graph or list out our bins. A lot of that's happening in our head as we look at the graph and understand what's going on. Now we're just going to be asked some questions about this graph now that we know how to read it. The first question asks us, what range of values would fit into the first bin? Well, we already talked about that. That was the values from 0 to 19. And our last bin ranged from 80 to 99. Next we're asked, what's the frequency for the second bin? That means how many data values fall in the second range, from 20 to 39. And we realize that that's 4, because that bar has a height of 4. Next we're asked, do any of the bins have the same frequency? Well, yes, as we saw above, 3 of the bins had a frequency of 5, a height of 5. So we'll say yes, bins 3 through 5. That's a proper way to name these, as this is the first bin, second bin, third bin, fourth bin, and then the 5th bin. Next we're asked how many data values were in the set. Well, this is a pretty easy thing to figure out. Since we know there's 8 in the first, 4 in the second, 5 in the third, 5 in the fourth, and 5 in the fifth, we can add up those numbers, which adds up to 27, to realize that there were 27 data values. Just a fun fact, that means that Julio Franco played 27 seasons in the major leagues. The next question is going to ask us to get specific about one of the data values within the data set. It's going to ask if it was possible that he had a season with 25 RBIs. And we're only going to make this decision based on what we see in the histogram. Well, if we look at the histogram, we see that there were 4 seasons in which he had somewhere between 20 and 39 RBIs. But one of the limitations with a histogram is you don't know what the individual data values are within a bin. You just know that there's 4 within the range of 20 to 39. So we don't know if he had a season with 25 RBIs, but we do know that it's possible he did. The follow-up question is, did he ever have a season with 105 RBIs? Well, from our histogram, we see that the largest bin is between 80 and 99 RBIs. So 105 would be outside of the last bin, so it's not possible. So we know for sure that it's not possible he ever had 105 RBIs in a single season. Now, the final question on this topic is going to help us to understand how the bins work. We're told that one of the seasons in our original data had 26 RBIs, but that was an error, and it's actually supposed to be 43. And they ask us, how would this change the histogram? Well, if the original number said 26, that fell in this bin. But if that's wrong, then the frequency of this bin is one too large. And if instead of 26, we're going to use 43, that means we need one more item in this bin. So we would have one less item in bin 2 and one more item in bin 3. So to sum this up, I say bin 2 will have one less data value and get lower, while bin 3 will have one more data value and get higher. Now we're going to move on to talking about one of the valuable things you get once you've constructed a histogram, and that's information about the shape of the data. Datasets can take on many different shapes, and three of the key ones are left skewed, right skewed, and symmetric. A symmetric graph starts low, ends low, and peaks nicely in the middle. A right skewed graph will feature a tail to the right side of the graph, where a left skewed graph will feature a tail to the left side of the graph. This is summed up here and with these two pictures. Let's finish things off by taking a look at three examples and determining their skewedness. In this first example, I see a long right tail without much of a tail to the left. This tells me that this is right skewed. In the next example, I see tails to the left and right with a nice high peak in the middle. This tells me it's symmetric. And on this last example, I see a long left tail without much of a tail to the right, meaning that this is left skewed. To summarize this lesson, a histogram is a graph that shows how many data values fall in different ranges of values, which we call bins. If one of the ends of the graph features a longer tail, we call the graph skewed in that direction. So if there's a left tail, we call it left skewed, and if there's a right tail, we call it right skewed. If the graph starts and ends low with a peak in the middle, we call that symmetric. If you came away with anything else, write that down now. Otherwise, we'll see you in the next lesson.